Hi dear students, in this video we are going to study about the transpose of a matrix. The transpose of a matrix, as you see in the definition, is formed by writing its columns as rows. So we are going to write the rows as columns. So the dimension m times n matrix, it's going to be n times m matrix in a transpose, and all the rows are going to be written here like as a column here. Also, there is one simple example here, like A is equal to 5 minus 571, and this the transpose of this matrix A transpose is going to be like minus 571 down as a column. This row is written as a column, and as you see, 3, 6, and minus 2 written as 3, 6, and minus 2 as a column here. This row becomes the column, and we get the A transpose like this. Okay, here there are some simple questions, and we are going to make these are transpose. Here A transpose, it's going to be rows going to be column, which means that when you get this row here like 2, and this row column, it's going to be 8. So this is the transpose of the first metric. Here B transpose, if we are talking about, it's going to be equal to, again, 3 by 3 matrix it's going to be, and this row it's going to be column like 1, 2, and 0, then 2, 1, and 0, 2, 1, and 0 here, 2, 1, and 0 like this here, and this one by 1, 2, 1, 0, 2, 1, 0, I'm writing down, and 0, 0, 1 it has to be, 0, 0, 1 it has to be. This is the transpose of B transpose also we can say. Yes, and the last one, C transpose, it's going to be equal to 0, 1 here. As a column I'm going to write 0, 1, then 2, 4, and 1 and minus 1 it has to be. And I'm going to write the dimensions here. Here there are 2 rows. This is 2 times 1 matrix, but the A transpose, it should be 1 times 2 matrix. Here this is 3 by 3 matrix, so it's going to be 3 by 3 matrix again. And this is here 3 by 2 matrix. It becomes 2 by 3 matrix. As you see, the dimensions, they are switching their places. 3 by 2 becomes 2 by 3 in A transpose. Okay, here we have some examples like A times A transpose, what it is. Here A is equal to cosine theta, sine theta, minus sine theta, cosine theta. We are going to solve this question by using some also trigonometric methods. Firstly, let me write A here. A times, to find the A times A transpose, sorry, A times A transpose is going to be equal to cosine theta, sine theta here, minus sine theta, this is, and cosine theta. And now I'm going to write as transpose as the rows to columns, which means this is going to be cosine theta, then I'm writing down sine theta, and here minus sine theta, it should be, this is the second row, becomes second column here, and cosine theta down. Okay, now what is A transpose? A times A transpose, let's find that one. But remember that here we are going to, when we are multiplying 2 matrix, we are multiplying rows by the columns. So I'm going to show like this here. So the resultant matrix, it's going to be equal to, I'm going to change the color by the way, cosine times cosine theta, cosine square theta. Sine times sine theta is going to be equal to sine square theta. Okay, and the first row, first column, we finished. First row, second column, we are coming. And cosine theta times minus sine theta, minus cosine theta times sine theta, it's going to be, and plus cosine theta times, cosine theta times minus sine theta minus cosine theta sine theta, plus sine theta times cosine theta. Sine theta times cosine theta, it has to be, this is the second, first row, second column. It should be, now I'm writing here the second column, which is minus second row, sorry, it's minus sine theta times cosine theta, again minus sine theta times cosine theta plus cosine theta times sine theta, cosine theta times sine theta. Then here it's going to be minus sine square, minus sine times minus sine, it's going to be plus sine square theta. Cosine plus cosine theta times cosine theta is going to be equal to cosine square theta. Here, probably you're going to learn this one in trigonometry, and maybe you haven't studied about the trigonometric identities, but let me remind you about the trigonometric identity here. And sine square x plus sine square a times cosine square a, it should be equal to 1. This is the first thing here. So these two, sine square theta times cosine square theta, or cosine square theta plus sine square theta, it should be equal to 1. This is the first part. And minus cosine theta, sine theta, and sine theta, cosine theta, normally these are same terms. This is like a times b plus minus ab, like here, let me write minus ab plus ba, actually this is ba. So when you add these two, this is going to be equal to 0 normally. Okay, so with respect to this one, here this should be 0 here, and this should be here 0, minus sine theta cosine theta. Okay, and this is sine square plus cosine square, again sine square a times cosine square a, it's going to be equal to 1. That's why the result of a times a transpose, it becomes 1 0 0 1 or 1 0 0 1 here. Okay, let's continue with another exercise. Or here there's a properties of the matrix transposition. Here a transpose is not affecting the addition operation, like you're distributing the powers here, and distributing the powers. A transpose plus B transpose is equal to A plus B transpose. This is not affecting. And if you get the double transpose of the transpose of transpose, you can get the main matrix again. And scalar term is not affecting the transpose operation. And this is the last one, and the most important maybe. A times B transpose, it should be equal to B transpose times A transpose. And we are going to prove that by using this question here. Here there's no space to solve this question. That's why I'm going to use another place for this one. Here I have recopied this one, and A times B transpose. Firstly, I'm going to find, I should find what is A times B. Okay, A times B is equal to, I'm going to write here 2, 1, minus 2, minus 1, 0, 3, 0, minus 2, and 1. Here this is 3 by 3 matrix times 3 by 3 matrix times here B is equal to 3, 1, 2 minus 1, and 3 and 0. Here this is 3 rows and by 2 columns matrix, and the resultant matrix, it's going to be again, and the resultant matrix, it's going to be 3 by 2 matrix. We know that one. Here the C, but let's find the C firstly. If you remember, I was shading like this. Here rows by the columns, we are going to multiply for multiplication of matrices. I'm going to do these operations as quick as possible. That's why directly I'm going to multiply, like 2 times 3 is equal to 6. I'm going to write plus 1 times 2 is equal to 2, and minus 2 times 3 is equal to minus 6. It's going to be plus minus 6. It's going to be minus 6. Okay, then this is first row, first column. First row, second column. 2 times 1 is equal to 2. 1 times minus 1 is equal to minus 1. Minus 2 times 0 is equal to 0. It has to be. Then I'm going to continue with the second row here. Here, this one, like, I want to change the here. This one might be like this, okay? Then minus 1 times 3, it's going to be equal to minus 3. Minus 1 times, pardon, 0 times 2 is equal to plus 2. 3 times 3, it's equal to plus 9, it should be. Minus 1 times 1 is equal to minus 1. 0 times minus 1 is equal to plus 0. And 3 times 0, it's going to be equal to 0. And we are coming to third row, first column. 3 times 0, 0 times 3, it's going to be equal to 0. Plus minus 2 times 2 is equal to minus 2. I'm sorry, minus 2 times 2 is equal to minus 4. 1 times 3 is equal to plus 3. It's going to be. Then here it's going to be equal to, this is my 0 times 1. Minus 2 times minus 1, it's equal to plus 2. And 1 times 0, it's going to be equal to 0. Okay, let's continue with the A times B matrix. A times B is equal to, it's going to be 6 plus 2 minus 2, it's equal to 2. 2 minus 1, 0, it's equal to 1. Minus 3 plus 2, it's equal to minus 1 plus 9, it's equal to 8. And here, minus 1 plus 0, it's going to be equal to minus 1. 0 minus 4 plus 3, it's equal to minus 1 here again. And 0 plus 2 plus 0, it should be equal to 2. This is A times B. What about A times B transpose? It's going to be equal to, rows becomes columns, which means 2, 1, and 8 minus 1, minus 1, and 2, it should be. Okay, I'm going to find now with different color. I want to do this one. Firstly, I want to find A transpose, what it is. A transpose is equal to, going to be 2, 1, minus 2, and minus 1, 0, 3. You should go like this, you know, and 0, minus 2, 0, minus 2, and 1, minus 2, and 1. This is A transpose. What about B transpose? It's going to be equal to, here, 3, 1, 3, 1, 2, and minus 1. Sorry for this. Okay. And 2 minus 1, and 3, 0, it has to be. Then B transpose times A transpose, we need to find what it is. A transpose, it's going to be equal to, here, 3, 2, 3, 1, minus 1, 0 times, it's going to be equal to 2 minus 1, 0, and then 1, 0, minus 2, and minus 2, 3, and then 1, it should be. If you remember, we are multiplying rows by the columns. I explained this one here, these rows. Let me change the color here. This is the way here. And let's start to multiply each row by each column. Here, 3 times 2 is equal to 6. 2 times 1 is equal to plus 2. 3 times minus 2 is equal to minus 6, it's going to be. And 3 times 1 minus 1 is equal to, 3 times minus 1 is equal to minus 3. 2 times 0 is equal to, 2 times 0 is equal to 2. And 3 times 3, it's equal to plus 9, it should be. And the next one, 2 times 0, I think here I made a mistake, the same mistake here. Minus 3 times, this is second row, minus 3 times 1 is equal to minus 3. 0 times 2, it should be equal to 0, but I have written here 2. I made the same mistake here also. So let me correct both mistakes in the video. Here, this both it's going to be here 0. Here also 0 it should be. I made this similar mistake in both part. Here, then this is going to be equal to 0. Then 3 times 3 is equal to 9. Yes, I correct that one. And by the way, I forget to write there, minus 3 plus 9 is equal to 6. It should be. Here, this should be 6. This should be 6. So the transpose here, it's also should be 6. This is 6, and this is 6. It's going to be 6 and 6 here. And let me continue to this question. Here, 3 times 0 is equal to 3. And then here, 2 times minus 2 is equal to minus 4. And 3 times 1 it's equal to 3. It's going to be 3 times, yes, 3 times 0 is equal to, sorry, I confused. 0. 2 times minus 2 is equal to minus 1. 3 times 1 is equal to plus 3. It should be okay. Then 1 times 2 is equal to 2. Minus 1 times 1 is equal to minus 1. And 0 times minus 2, it's going to be equal to minus, actually plus 0. 1 times minus 1 is equal to minus 1. Minus 1 times 0, it's going to be equal to here 0. And then 0 times 3, it's going to be equal to plus 0. And this is the last part now. 1 times 0, it's equal to 0. Minus 1 times minus 2, it's going to be equal to plus 2. And 0 times 1, it's going to be equal to 0. So these are equal to 6, 2, and minus 6. This is going to be equal to 2. And here, this is minus 3 plus 9, it's equal to 6. This is minus 4 plus 3, it's equal to minus 1. And 2 minus 1, 0 here, it's equal to 1. Minus 1 plus 0 plus 0, it's equal to minus 1. And 0 plus 2 plus 0, it's going to be equal to 2. And here, as you see, this is B times A, B transpose times A transpose, it's going to be. And this is the last part. A times B transpose, as you see, they are equal to each other. They are equal to each other, so they are equal to each other here. B transpose times A transpose, it's going to be